Karthik is a research staff member in the Power Aware Systems Department at IBM's Austin Research Lab. Karthik works on power management and systems design, and today he's going to talk to us about a researcher's window into power management. Very good, Karthik.
So I'm Karthick Rajamani. I'm a researcher from IBM Austin, as Jason mentioned, and right now I'm going to give you a window into power management, which is an enduring challenge for the computing industry. So I began my career in 2001 when I joined the IBM Austin Research Lab after finishing a PhD at Rice University. At the time, the lab was designated as the low power center for IBM to look at all aspects of power consumption in the computer, right from silicon technology to VLSI circuits to computer chips and going up into the system design and the software and firmware for runtime management. So I began with two projects. The first was to enable the software stack and architecture for rapid voltage and frequency scaling, technology that was built into a processor designed in the lab for handhelds. Now, the embedded system space, the handhelds belong in the space, was the first to recognize the value of dynamic power management because of the limitations of battery technologies. And that continues to this date, where embedded systems still deliver a lot of benefit from dynamic power management. The second project was looking at how do we leverage the rapid power up and power down capabilities that was showing up in low power processors for a super dense blade server design that the lab had come up with. Now, the blade servers were at the kind of the other end, where they were trying to pack a lot of compute power, and that translated to electrical power in a very small form factor. And this resulted in cooling challenges and associated thermal problems, and needed dynamic power management again to address the solutions, provide solutions there. So the team from our lab worked on various topics in this space, and there are a lot of industry firsts for IBM from the work done there. We were the first to introduce onboard server power monitoring, and subsequently we introduced server power capping technology into our blade servers. After that, we began multiple years working with the power systems organization, where we introduced the energy scale technology. And on the Power 6 processors, we were able to get to the highest frequencies seen in the industry, and maybe a record even to this day, I think, where we were able to get to like 6 gigahertz kind of frequencies. And that was because the dynamic power management capabilities were able to manage the peak power and thermal issues that can come when you're trying to go for such high frequencies. Going forward with Power 7, we we were the first to introduce dynamic power management for the memory system, and then also added specialized frequency scaling for multi-threaded processors, an onboard power controller on the Power 8, which could coordinate very effectively both in-band and out-of-band power control. These were all many success stories for us. After a dozen or so years of doing this, we thought it was time to move on. Actually, that was not the case, but that's what we thought at that time. And then IBM was coming into the cloud arena in a big way at that point, so we thought the skills from the team could be better applied to this new space to address the challenges and develop new technologies for the cloud infrastructure. So a year or so after this transition, I got a call from a colleague of mine. His name was Malcolm Ware. He was part of our research team. He contributed to a lot of success in the power management space, but then had moved to kickstart a new innovation team in the newly formed cloud organization. So he called and said, this power management thing that we thought we are done with, we still have issues with it, but now at the data center level, are you guys interested in looking at this? So what was this issue? So imagine you're the head of a big cloud service company. You wake up one fine morning, look at Twitter, and your company is being bashed by your customers because your service has gone down. And you have to get back to Twitter and apologize and appease them. This is not a good situation for you, for anybody, But unfortunately, it's not a very uncommon situation. Just in 2016, there were numerous outages, airline delays, internet service providers going down, major issues with cloud service providers, and many of these could be traced to problems in their power infrastructure in their data center. So whether human or other factors can cause overload of circuits in the power infrastructure, and when an overload happens, the circuit breakers will trip to protect the infrastructure, but what that means is that servers that are downstream from the circuits are powered off, and that means the services running on them are going to be down. And so there are known ways to address this problem in the data center, and that's by using some kinds of redundancy in the power infrastructure. So think of it this way, like you have a utility feed providing power to the data center. What if we have two feeds from two different utilities coming to the data center? So even if one were to go down, the other can still provide power to the data center. And this idea of redundancy can be applied at every level of the power infrastructure, to transformers, to UPS, the power panels on the data center floor, the power strips in the rack, right down to the power supplies on servers. They could all be redundant. And this gives you availability, but it comes at a cost. And when you look at our cloud data centers, the infrastructure, the data center infrastructure can be pretty big for them, and the cost can run into tens, if not hundreds of millions of dollars for a hyperscale type data center. Now asking them to say, okay, now you go and spend some more on this because you have to improve the power availability, the availability of the power infrastructure to add redundancy, that's like asking too much of them. And so we come to two competing issues. One, you want to save your power infrastructure, have it available, or you might face angry customers. And second, you want high utilization of this expensive infrastructure, otherwise your cloud business is going to be hemorrhaging profits. So is this dichotomy real, or can we have both? And that brings me to the newest chapter in this power management story, where we want to do a data center-wide power monitoring infrastructure and power control infrastructure that can deliver both high availability as well as high utilization for the infrastructure. And that's what we are going to do now. And I believe that, I won't go into the technology for it in detail, but I believe that a cloud native approach to doing such a service which has a view of the power control topology for the data center, the power delivery infrastructure for the data center, can actually be the solution for this challenge. Now, no journey is fun alone, and I've had a lot of wonderful colleagues working with me on this journey from research, from the systems organization, and more recently the cloud organization. And a big thanks to all of them for sharing this journey with me. And thank you all too for taking a peek into this window to power management. Thank you.
Very good. It's easy to forget that it all goes back to power, right? Power still is the heart of the tech revolution.